All right, let's plug into the very nervous system of the Boeing 737. Today, we're diving into ATA Chapter 31, which covers all the indicating and recording systems. I mean, think about it. This is how the plane feels its way through the sky, remembers every single thing it does, and talks directly to the pilots. It's really the brain and the nerves of this incredible machine.
So here's the game plan for how we're going to build this cockpit brain. We'll start with the big picture, what these systems are all about. Then we'll get into the aircraft's memory, the famous black box. From there, we'll check out the interfaces like clocks and printers, then move to the dazzling glass cockpit displays. And we'll wrap it all up with the critical warning systems, the ones that act like the plane's reflexes.
Okay, first things first. We need to lay the groundwork. What's the whole point of these systems in AT Chapter 31? Well, it all boils down to managing a massive flow of information. So you see, these systems really have two main jobs. The first job is happening right now, in real time, giving the pilots the essential data they need to fly the plane safely. The second job is all about the future, creating this incredibly detailed record of the entire flight, which is absolutely vital for maintenance, analysis, and, of course, for safety investigations.
Now let's talk about the aircraft's memory. This is the Flight Data Recorder System, or FDRS for short, and you definitely know its most famous part, the black box.
The whole purpose of this system is to be the ultimate data hoover. Seriously, it's constantly collecting hundreds of different parameters every single second. It's listening to sensors all over the aircraft, from where the flight controls are to what the engines are doing, and it saves every bit of it in a super protected unit.
And this system isn't just one box tucked away in a corner. It's spread all throughout the plane. You've got test plugs right up in the flight compartment, processors in the electronics bay down below, an accelerometer in the wheel well, and then the recorder itself that's way in the back in the aft cabin. It's everywhere.
So the heart of this whole operation is a component called the FDAU, or the Flight Data Acquisition Unit. You can think of it like a central processing hub, or maybe a universal translator. It takes in all these different signals, analog, digital, you name it, from countless sensors, and it converts them all into one clean, standard digital format. Then it sends that unified stream of data onto the recorder.
And that data stream's final destination is right here, the flight data recorder. This thing is the secure vault. Inside, it's got solid-state memory that holds on to the last 25 hours of flight data. And believe me, it is engineered from the ground up to survive just about anything you can imagine, all to protect the priceless information inside.
Just how tough is it? Get a load of this. The memory unit is built to survive an impact of 3,400 Gs. To put that in perspective, that's way over 100 times the force a fighter pilot can handle. And that's not all. It's also designed to take a crushing force of 5,000 pounds, handle the pressure of being 20,000 feet underwater, and withstand a fire hot enough to melt aluminum for 30 minutes. It is an absolute marvel of engineering built for one thing and one thing only: survival.
Okay, next up, let's look at a couple of the most direct ways the crew interacts with this data. We're talking about the clocks that keep everything in sync and the printer that can give them a physical copy of information. You see those clocks on the instrument panel? They do way more than just tell the pilots the time. They are the master timekeepers for the entire aircraft. They synchronize other major systems like the flight management computer and that FDAU we just talked about. And that precision is absolutely critical for everything from navigation to making sure every single piece of recorded data gets a perfect timestamp. And how does it stay so accurate? It gets its time straight from the GPS satellites. And sometimes you just need a hard copy. That's where the flight deck printer comes in. It can print out reports from systems like ACARS, which is basically the plane's text messaging system to the ground, or even from the data recorder system itself. It's a pretty simple and tough little gadget, with just a few switches to run a test, reset it, or feed the paper. All right, now for the really cool part. Let's get into the core of how pilots actually see and understand all of this information. We're talking about the Common Display System, or CDS. This is the magic behind the modern glass cockpit. If the FDR is the aircraft's memory, then the CDS is its consciousness. It takes a truly mind-boggling amount of data from just about every system on the plane, and then translates it all into these beautiful, easy-to-understand graphical displays that the pilots depend on every second. Now, it's a pretty complex system, but it's all built around redundancy. The real brains of the outfit are two computers called Display Electronic Units, or DEUs. Think of them like super powerful graphics cards. They generate all the images and data that get sent to the 6 main screens in the cockpit, which are called the display units.
What's really clever about this is the layout. It's not random, it's all about priority and what the pilots need to see. So the most important flight info, the primary flight display, is smack in front of each pilot. Right next to that is their navigation display. And then the info they both need to see, like the engine displays, that's right there in the middle, easy for both of them to glance at.
The system is also incredibly smart. It has backups for its backups. So what happens if one of those screens goes dark? Well, the DEUs automatically kick in and reroute the information. For example, if the pilot's navigation display fails, the system instantly combines that navigation data right onto the main flight display. It ensures the crew never, ever lose access to critical info. And finally, let's talk about the airplane's reflexes. These are the systems designed to do one thing: get the crew's attention and get it now. The master caution system has a really important job. It's an attention getter. You have to remember, there are dozens of indicator lights on the overhead panels, outside of the pilot's normal line of sight. This system acts like a little tap on the shoulder, making sure they don't miss a new caution light that's popped on somewhere in the cockpit. So here's how it works. Let's say a light for equip cooling off turns on up on the overhead panel. Well, at that exact same moment, 2 big, bright master caution lights flash right in front of the pilots. That bright flash is the trigger. It's the plane saying, hey, a new problem has come up. Time to scan the panels, find it, and deal with it. So what's the big takeaway here? ATA Chapter 31 isn't just one thing. It's this whole family of interconnected systems that work together. They create the airplane's complete network to sense, to remember, and to communicate, all designed to record, interface, display, and alert the pilots.
And that kind of leaves us with a fascinating question to think about. As planes become more and more automated, how is this nervous system going to have to change? Is it going to be enough to just indicate, record, and warn? Or will the airplanes of the future need a whole new kind of consciousness to work with the pilots?